task scheduler. We are given an array of CPU tasks, okay, each labeled with a letter from A to Z and a number n, where n is the cooling period, which we'll know uh, further into the question. Each CPU interval can be idle or allow the completion of one task. Tasks can be completed in any order, but there's a constraint. There has to be a gap of at least n intervals between two tasks with the same label. And at the end, we need to return the minimum number of CPU intervals required to complete all tasks. So, what this question says is that we have been given some tasks, or let's say processors, sorry, processes, because it is CPU we are talking about. So we have been given some processes, and n is given, and n means uh, cooling period. So if you start a process, you need to wait n units to execute that same task again. Okay, that's what it means. So for example, we have this array where the elements are A, B, 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 and n is equal to 2. That means we need to wait for 2 units of time, or anything. Time. Let's take time. So the output would be 8, and the explanation is the possible sequence, or the sequence of execution of these tasks is A, B, and idle, and again A, B, and idle, and A and B. Until these tasks are all done, we need to execute this. So the here it has been given that after completing task A, you must wait two intervals of time because n is equal to 2 before doing A again. So how do we solve this? Uh, the first approach we are going to use is Max Heap. Okay, uh, and Max Heap was taught to you yesterday, and we have had the implementation of it with in the explanation given by Rishikesh. So we use the Max Heap to store frequencies of like how many times the tasks occur. Okay, this particular task occur. For example, A occurs 3 times and B occurs 3 times. So we are going to use Max Heap, and we are also going to define a cycle. Okay, so let me write it here. So first we are going to define, oh sorry, it's too much. Okay, so we are going to define a max heap, and since it was taught to you yesterday, I hope everyone knows what a max heap is. And if you don't, I'll just remind you that the largest element would be on the top, and its children would be smaller than the uh, root. Okay, root node. For example, this 4, 3, and 2, or something like this. Okay, so we are going to use this max heap first of all, and then we are going to define a cycle. So what does a cycle mean? A cycle means uh, the execution time and also the cooldown, sum of execution time and cooldown time. Okay, so what what is cycle to a process or a task is that if you execute this task, for example, let's say A, you need to wait a period of n plus 1. So this 1 means the execution time for A. Let us say that execution time of A takes 1 unit. Okay, so 1 means that, and n means cooldown period or cooldown time. Next, we are going to use a queue data structure, and then we are going to use what is that, array list. Okay, we are going to use array list to store all the to store all the frequencies and put it into the max heap again. Okay, and Q is for uh, uh, converting or minimizing the frequencies after the task has been utilized. So we are going to use these data structures. One is max heap, and the other is queue, and the other is array list. Okay. So the first thing we do is we need to store the frequencies. And how do we do that? We will do that by creating an array. Okay. Array frequency is equal to new. Sorry, int, and the size is going to be the number of English alphabets we have, which is 26. So each letter has its own space. Okay, and then we are going to store the frequencies. Okay, so if a comes three times, we are going to store a in its position, and we are going to store 3 because it is repeating 3 times. So for that, we will run for each loop ch, and we are going to iterate over tasks array because all the letters are in there, and we are going to use this use so we do this operation for adding the frequencies if they occur, if that letter occurs in their respective indexes. So since arrays start from 0th index, a will be at a 0th index. Okay, so if you subtract a, if the character is a and you subtract a, you get at that index which is 0. And if character is b, ch is b, then b minus a, that means you get the difference of 1. So you store the frequency of b at its position, which is 1. So this is a simple way of doing it. Instead of converting the character into number and then subtracting the current character, uh, current character, converting the current character into number and then subtracting again. Okay. So this is all about storing frequencies. Now what we do is we store these frequencies in max heap. And how do we create max heap? So we will be going to create a priority queue. Okay. E. Okay. And integer. And let us name this as heap max. Okay. And the new priority queue. And for that, we are going to use this. Since we are using max heap, by default this would be in min heap. So since we want max heap, we will do collections dot reverse order. Okay, so what does this mean? We reverse order because we want to convert the default min heap to max heap. We are going to use this. Okay, just minimize this. Okay, all right. So after this, we are going to iterate over the frequency array we have just created, and then we add these frequencies to the max heap. Okay, so how do we do that? We'll just use for each loop again, and this time int f for the frequency, and we'll iterate over the frequency array. And mind you that we have to add only if the number is greater than 0. Why? Because if you don't take care of this is an edge case. If you don't take care of this, you're just going to add all of them. Okay, since arrays start from 0, an array is initialized from 0. If you don't take care of this f is greater than 0, you're just going to add all of them, and we don't want a max heap to be filled with zeros. And then to add this, we'll just call add method, and what we are going to add, f. Okay, which is the frequency, respective frequency of the task. Then we need to keep track of time. uh, you just can simply take it out of the max heap and just do anything. This is about time, and n is given, and n means a time. Okay, it means cooldown time. So we are dealing with time here. And to keep track of time, we'll just create a variable. Okay, and let us name this as time, and we'll initialize it from 0. Okay, now we will not just be clearing out max heap in one iteration. We are going to decrease the frequencies, and then push it into the max heap, and then again, sorry, did I say increase? No, decrease the frequencies and push it into the max heap, and then again take it out of the max heap, and then just decrease it until the max heap becomes empty, or the frequencies become 0. And to do that, we have a loop. We are going to create a loop which is while heap is not empty, heap max is empty. Okay, now uh, we are going to decrease the frequencies in this loop, and because we will be using that later. Once you use that letter, its frequency should or must be decreased. And to keep track of or store what the frequencies are after being decreased, we will use an array list. Okay, and since I have already defined what a cycle is. A cycle means the total period of time uh, for a task to be executed again, for the same task to be executed again, which is the cooldown time plus the execution time of that task, which we assume it to be 1. Okay, n plus 1. Okay, and then we are going to run a while loop again. This time we are going to check whether cycle is greater than or equal sorry, greater than 0. Okay, and then we are also going to check whether heap max is empty or not. Okay, then we can just pick it out and just do something, an operation on it. So we need to store that number somewhere. So here comes the variable in which we are going to store the element, and the method to pop this. We are
भैया
going,
पूछ रहा था कि n+1 क्यों लिया?
acha, cycle n plus 1. See, n plus 1 means that, see, let me just tell you, हमने इधर ए एग्जीक्यूट किया और n यूनिट्स ऑफ टाइम वेट किए हैं. and to execute A again, you need to wait this much period of time. We are assuming that this execution of this A, the first A, takes 1 unit of time, and since we have to wait n units of time, this is n. And after this, we can execute A. Okay. So for this to happen, you need to wait this much amount of time, and cycle represents this. So let me just repeat. Frequencies will be stored in 26 sized array, which means that we are going to store frequencies of each letter in its respective places. Then we are going to store the frequencies by iterating the array, and then we are going to create a max heap in which each frequencies are added which were previously done in this loop. Okay, we are going to store all the frequencies which were calculated uh, before the creation of heap max, and we are going to put these frequencies into the heap. Then we are going to keep a track of time because the question involves time. Okay, we are going to increase this time 1 unit, okay, as we go. So or let's say for example 1 second. Okay, we are going to increase time 1 second by 1 second. Then we are going to run a loop which we'll check whether heap max is empty or not. And if it is not empty, we are going to create an array list to keep track of the frequencies after being executed. So for example, here I have I have three A's. So initially I will store this three A's in max heap. But after execution, I should know that there are two A's left. And to represent that or to indicate that, we are going to use list. We are going to use the help of list to store that the number of frequency has been decreased by one because you have executed one of the A you had previously. So for that, we use a list, an array list particularly. Then we are going to keep track of cycle. Okay, cycle means cooldown time plus the execution time of that one particular task which we assume to be 1 unit. Then we are going to use a loop which will check whether the cycle is greater than 0. Why? Because a cycle is ended when the cycle is, when we reach to the end of cycle, and since you are decreasing it by one, it will eventually be 0. And for that to not happen, we are going to stop at cycle greater than 0. Okay, we will not let cycle be equal to 0. And then we are going to check whether heap map is empty or not. Then we are going to take the element. Okay, we are going to take the element which is the root node. Okay, we are going to store the root node or the root element into an variable called current.
Makes
Frequencies,
sense.
we are adding frequencies to the max heap. See here, I have iterated over the frequency array. See frequency, and I have added these elements or the frequencies to the max heap. Now if I poll this, I will have the maximum frequency. Since this is a max heap and the root element is the maximum frequency, I am going to store this maximum frequency. So the logic here is that we will first okay, we will first execute the task which has maximum frequency. This is the thing I just missed. Okay, I forgot to mention this. Now if we have three A's, okay, and let's say 2 Bs. I will calculate all the frequencies of each task, okay, and then execute the task which has the maximum frequency. That is why we are using the max heap. I forgot to mention that. We are using max heap to execute the most frequent task, okay. Now you might say, what if there's another B? Actually, that is a test case, but what if there is another B? Well, we are just going to just let the heap pick for us, okay. That is why here it has said a possible sequence. We are going to let the max heap decide what the letter it wants to give us. It may give us B or it may give us A, okay, because the frequencies are equal. And if they are not equal, so for example, if this B is not present and we have 3 A's and 2 B's, we are going to pick the maximum frequent task and execute that. So we are going to move on to the next. Okay, after storing the maximum frequent task, okay, since we are executing it, the frequency of that particular task will decrease, okay. uh, since the test case given to us is 3 A's and 3 B's, we are going to let heap max pick the element for us, okay, and then execute it. Now if it executes, the frequency which is originally 3 will drop to 2, and to indicate that it won't do it by itself, we have to do something. So for that we will indicate it by decrementing it. After that, we are going to store this into a list. Now I have already said what the use of list is. The use of list is to store the decremented frequencies. That's it. Why? Because we want to execute it until all the tasks are done, and the frequency of tasks are stored in heap, and the decremented frequencies after executing are stored in lists. Okay, I hope that is clear. And we are going to add the new frequency to our list. Okay, dot add current. And after this has been added, this means that it has been executed. Since it has been executed, we are going to increase the time by 1 second or 1 unit of whatever time you choose, and then decrement the cycle. Okay, we have initialized cycle with the execution time of the particular task and the cooldown time, and now we are decrementing it to say that one of the uh, the one of the slot of the cycle has been filled. Now after this, after all the what we say, the cycle has been decremented and the time, and we keep track of time, and after every frequency has been added, after every decremented frequency has been added to the list, what we are going to do is we are going to add these frequencies into the heap again. Now be careful that heap max will be empty by now. Okay, after this loop heap max will be empty, because until heap max is empty we are going to execute this, and we are also doing the removal of that node. Okay, eventually it will be empty, and after it will be empty we are going to start with the empty heap, and now we are going to add the decremented frequencies from the list. Okay, and that is temp. Okay, we are going to iterate using for each loop, and then we are going to add to the heap, add the decremented frequencies to the heap. So we are going to add the decremented frequencies. Now, after adding, or if there is nothing to add, we will make sure that heap is actually empty, and if it is empty, we are going to break out of the loop. Okay, if even though sorry, not even though, after adding the decremented frequencies to the list, and after everything has been finished, if the frequencies become zero, there is nothing to add. Since there is nothing to add, the heap max would be empty, and if it is empty, we are going to break from the while loop, which is this. Okay, this main while loop, we are going to break from this. And if it is not empty, we will go down further, and we will add this time. Okay, we will add the number of cycles to the time. Okay, now uh, you might ask what or why did we do this. The leftovers cycle. Okay, so we are decrementing the cycle period as we add the decremented frequencies, as we execute the task. Now, as we execute the task, the cycle would decrease, but the remaining cycle time would indicate that there is an idle time. Okay, so for example, I say that I have executed A. I'm taking this example, and since n is equal to 2, I would execute B next. Okay, since there is nothing left, because only after 2 units of time should A execute, and after 2 units of time should B execute. Now we have we have only A and B left. Since we have to wait for the execution of A, we will leave this uh, unit or this slot as empty, which means that it is idle. And to indicate this is idle, the cycle would have some value remaining. Okay, that means it has not been utilized fully, and this cycle value should be added to the time. It is just like FCFS. Okay, if there is if the waiting time is too much, you have to add the idle time to the main time. That's what it means by this code line. Okay, time is equal to time plus cycle, the present time plus the idle time. Okay, let me write this: present time plus idle time. Okay, that's what this line means. And after all this is done, we'll come out of the loop and we'll just return the time. Okay, so what does time mean? It's basically the uh, total of the task executed. Okay, so A, B idle, and again A, B idle, and then A, B would be executed, and the time we will receive is 8, because each task approximately takes 1 unit of time as mentioned. Okay, okay, this is the dry run. So we'll create an array. Oh, sorry, the lead code has already created an array for us. Okay, and we'll start with this array, and n is equal to 2. and then we'll be going to create an array for frequencies, and then add all the frequencies. Okay, 0 means A and 1 means B. Okay, 0 means A and 1 means B. Break out of the loop, and we are going to create a priority queue instance, and then we are going to loop over the frequencies, and we are going to create a heap. It won't do much because all of the other things are 0. It will oh sorry. So it has been done, and we move on to the next, which is time equal to 0. Okay, and then we'll check. We'll be going to create an empty array list, and the cycle will be 3 because n plus 1 and n here is 2. Cycle is n plus 1, and then we are going to use this loop to iterate over the max heap. I mean, sorry, to store the decremented frequencies to execute that. So, for example, the first uh, the letter or the first task executed is has been put into current, which is 3. Okay, then we are going to decrement it. Okay, and then we are going to add it to the array list, and then again where was this? Okay, we're going to push this frequency into the current variable, and we are going to decrement the frequency because it has been executed, and then we are going to add this value to the array list, which is 2, and then we are going to increase the time. Okay, and then we are going to decrement the cycle, and we are going to do that again. Okay, since there are two tasks, for each task we have been decrementing the frequencies. Okay, now the cycle will be 1, but here the heap will be empty. Even though the cycle is 1, the heap will be empty, so we are going to break out of this loop. Then we are going to add the element of this array list to the heap, and after this we are going to add all the decremented frequencies to the heap. Okay, and then since heap is not empty yet, we are going to add the idle time to our main time, which is 3, since the cycle was left to be 1, and we are going to add this one to the time to indicate that at 1 unit of time has been passed for idle time. Then we are going to run the loop again. Okay, let us move to the last. Okay, so the array list has elements 1 and 1. Okay, it does not matter in what order you execute. If you execute a task, it should not be repeated unless n units of time has been passed. That's the main concept here. Okay, it does not matter in what way you execute, because here it has been said a possible sequence, so it does not matter that much. and then we're going to loop again. We are just going to return the time, which is 8, and we are going to print it.